All right, let's do some Mathity-Math. It says you're given, line 1 is 6y minus 12x minus 12 equals 0. Line 2 crosses the x-axis at point 80 and is perpendicular to L1. Okay, big clue there. Okay, so part A says find the equation of L2 in the form of y equals mx plus b. All right, so the first big clue here. We know L2 is perpendicular to L1. So that means we need to find the slope of L1 and take the opposite reciprocal of it. So first, to find our slope, we should move this into y equals mx plus b form. I'm just going to do that up here so we can see it nicely. So if I added 12x and 12 to both sides, I'd get 6y is 12x plus 12. Cool. I'm going to divide everything by 6 to get y all by itself. So I get y is 2x plus 2. Okay, great. Okay, so that right there tells us that the slope of L1 is 2. If the slope of L1 is 2, then we know that the slope of L2 would be negative 1 over 2 because the opposite reciprocal. So we know that our L2 line so far is y equals negative 1/2 x plus something. And we don't know that something. Here's the second clue. They said it passes through the point 80. So if it passes through the point 80, we can just plug in those x's and y's, and then we'll have b. So this is an x, and this is a y, right? So plug those in. Okay, so it says y is 0. So 0 is negative 1/2. What's x? 8. Plus, 8 plus b. All right, a negative 1/2 times 8 is negative 4. So at this point, you'd have 0 is negative 4 plus b. Add 4 to both sides. You know b is 4. And now you have all the pieces for your equation. The equation for L2 is y is negative 1/2 x plus 4. All right, there you go. That is part A. That is L2. Very good. Okay, let's go down a little bit, see what's next. Then it says, given L3, I can't get straight here. Okay, L3 is parallel to L1 and passes through -2, -9. Okay, so for L1 we found earlier, I can just rewrite it for you. We found that L1 was y equals 2x plus 2. We did that at the very beginning of the problem. So they're telling you that L3 is parallel to L1. So then we know the slope is the same. So if we're looking at L3 and we're putting it y equals mx plus b form, it'd be y equals 2x plus b. Because we know the slope's the same because they are parallel. Okay, and we know it passes through -2, -9. So again, we just plug in the x, and we plug in the y. That'll isolate b, and you got your answer, okay? So y is -9 equals 2 times -2 plus b. -9 equals -4 plus b. Add 4 to both sides, and you know that b is -5. And there you go. Our L3 equation is y equals 2x minus 5. Woohoo! Good job. That's L3. Ta-da! Okay, next it says find the point of intersection of L2 and L3. Okay, so this is our L2, this is our L3. So all we have to do here is remember, like, when things intersect, they become the same thing. So for instance, you could say, I always like to say y is y, and now substitute in for your y's. So instead of this y, I'm going to say negative 1/2 x plus 4. And for that y, I'll say 2x minus 5. And they're the same thing because they're intersecting. Okie dokie. We isolate x on one side and get the constants on the other, and then we should be in business. So step 1, we subtract 2x from both sides. That's going to give us negative 2.5x. That's a half of 0.5. Okay. We subtract 4 from both sides, and that's going to equal negative 9. So at this point, we should have negative 2.5x equals negative 9. You divide negative 9 by negative 2.5. Let's see what happens. You get negative 9 divided by negative 2.5, 3.6. So we know that the x value of the point of intersection is 3.6. Okay, so now all we have to do is plug this x value into here or here, and we'll solve for y. That would be the point of intersection. I'm actually going to do both just to make sure I didn't make a mistake, because they should both work. They should both give me the same value, because when things intersect, they are the same. All right? So y is 2 times 3.6 minus 5. 2 times 3.6 is 7.2. So y is 7.2 minus 5. And 7.2 minus 5 gives you 2.2. So let me just draw it over here. Y is 2.2. I'm going to do it again with my other one just to make sure. So I just did this one. I'll do this one. Okay. So we have y is negative 1/2 times 3.6 plus 4. Okay, let's look at this. 3.6 times negative 0.5, negative 1.8. Y is negative 1.8 plus 4. Negative 1.8 plus 4 is, 2.2. So there we go. We know that the point of intersection right here, the x is 3.6 and the y is 2.2. So I'll just put it right here, 3.6 and 2.2. That's in parentheses because those are the coordinates. There you go. Here we go. Last one. Let's see here. It says, prove that the intersection of L2 and L3, okay, so that's that right there. So this is this right here, what they're talking about. That's that. It says, prove that this point lies on the parabola represented by the equation. Okay. This question is actually kind of meant to try to scare us away, right? Oh, I don't know how to find a parabola at the point. But it's nothing. All you have to do is plug in and make sure it creates a valid equation, and the answer is yes, that you've proved it. So instead of y, I put in 2.2. And real quick, let's pause this thought. No matter what long, convoluted, crazy thing you see here, as long as you can plug in your x and your y and check it, you can do it. Okay? There's no actual manipulation or anything like that. So it's okay. So 10.76 is x squared. So 3.6 squared. Okay, so let's do this like this. Let's see here. Okay, 2.2 plus 10.76 would give you 12.96. 12.96. If this is valid, if we could prove this, the 3.6 squared should give us this value. So let's see what happens here. 3.6 squared, and would you look at that? We proved it. It does lie on that point. Ta-da! All right, that's enough proof for me. Good job, you're done. All right, as always, you got any questions or comments, leave them below. And if you want to be notified when more Mathity-Math is coming your way, just subscribe to Mathity-Math. Thank you. Bye.